Hello, my name is Meghna and I'm a third-year biochemistry major. We will be working through problem number 10 from chapter 3 in this general chemistry workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem, then we'll go over it together. The question is asking, what is the percent composition by mass of the following compounds? So basically, we are trying to find how much of each element is in the compound compared to its total mass. Let's start with Prussian blue. The first step is to find the atomic mass of each element in the compound. Now, the elements in the compound are iron, carbon, and nitrogen. Iron has an atomic mass of 55.85. Carbon's atomic mass is 12.01, and nitrogen's atomic mass is 14.01. So here are all the atomic masses for each element. Now we have to find the number of atoms in each element. Let's start with iron. In this part of the compound, there are only 4 iron atoms. But in this part, since it's surrounded by a bracket with subscript 3, which distributes to each part of the compound in the brackets, that means there are 3 iron atoms in this part of the compound. Now we add them together, and there are 7 total iron atoms in this compound. Now let's find the number of carbon atoms and the number of nitrogen atoms in the compound. So this part can get a little confusing because carbon is part of the CN6 group, but it's also part of the FeCN6 group. So we have to take into account the subscript next to the parentheses in CN and the subscript next to the brackets. So let's start with the CN6 group. Since the subscript distributes to each element in the parentheses or brackets, we know in the CN group there are 6 carbon atoms and 6 nitrogen atoms. But in the bigger group, there's a subscript of 3. So in this group, we know there are 3 iron atoms and 3 of the CN6 group. So basically that just means 3 times CN6. So we figured out before that there are 6 carbon and 6 nitrogen in the CN group. Now all we have to do is multiply the 6 carbon times 3 and the 6 nitrogen by 3, which are both equal to 18, in order to get the total number of each of those elements in the compound. So to summarize, now we know there are 7 atoms of iron in this compound, 18 carbon atoms, and 18 nitrogen atoms. Now we need to find the total mass of each element in the compound. To do this, we multiply the number of atoms we found in the previous step times the atomic mass we found in the first step using the periodic table. So for iron, we found there are 7 atoms in the compound, and the atomic mass was 55.85. That should equal 390.95. So now this number is also the molar mass of iron in the compound, so the units would be grams per mole. For carbon, we found there are 18 atoms with an atomic mass of 12.01, and that should equal 216.18 grams per mole. For nitrogen, we found there are 18 atoms and with an atomic mass of 14.01, so that should equal 252.18 grams per mole. Now I'm going to hand it off to Christina to find the total molar mass of the compound.
Hi, my name is Christina and I'm a third-year biomedical engineering major. And right now we are going to find the total molar mass of the compound. This is simply done by adding up the total masses of each element that we calculated before with Megna. First we start with the 390.95 grams per mole, which is from iron. Then we add it to the 216.18, which is from carbon. And then we add that to the 252.18, which is from nitrogen. When we add these together, we get 859.31 grams per mole for our total molar mass. Now we are at the final step of finding the mass percent of each element in the compound. This is done by dividing the molar mass of each individual element by the total molar mass that we found in step 4. Starting with iron, we divide the 390.95 grams per mole by the total 859.31 to equal 0.455. We then multiply that by 100 to get the mass percent of 45.5%. We repeat this with carbon to get 0.252, and we multiply this by 100 to equal 25.2%. And again with nitrogen to get 0.293 multiplied by 100 to equal 29.3%. To check your work at the end, you can add up your mass percent and they should all add to be 100%. We are going to repeat this process to find the percent composition by mass of malachite. We will begin by finding the atomic mass of each element. For copper, it has an atomic mass of 63.55. Oxygen has an atomic mass of 16. Hydrogen has an atomic mass of 1.01. And carbon has an atomic mass of 12.01. Next, we count the number of atoms of each element in the compound. Starting with copper, it has 2 atoms. Oxygen has the first 3 in the CO3 section, and then the 2 outside of the parentheses distributes to the oxygen, so there is a total of 5 atoms of oxygen. Hydrogen, the 2 distributes as well to it, so there is a total of 2 atoms of hydrogen. And for carbon, there is only the single carbon atom. Next, we multiply these out to get the molar masses of each element. Copper is 127.1, oxygen is 80, hydrogen is 2.02, and carbon is 12.01. Now we add up the molar masses we calculated in the previous step to equal 221.13 grams per mole. Lastly, we are calculating the mass percent of each element in the compound. Copper is 127.1 divided by 221.13 to equal 0.575 multiplied by 100 to equal 57.5%. We repeat this with oxygen to get 0.362 multiplied by 100 to get 36.2%. Hydrogen's equals 0.009 times 100 to equal 0.9%. Lastly, copper equals 0.054 times 100 to equal 5.4%. And again, to check your work, you can add up all of your mass percents and they should equal 100%.